You know, I was standing in my kitchen the other morning, coffee mug in hand, and I noticed the bass from my speaker was um, vibrating the whole countertop. You could actually see these tiny, perfect little ripples in my coffee. And it just got me thinking, what if sound wasn't just something we hear? What if it, visually structures the world around us?
That is the exact question we're getting into today. We are doing a deep dive into cymatics, which is the study of visible patterns that are created by vibration.
Cymatics. Okay, and the name comes from Greek.
It does, yeah, from chema, which means wave.
And the beauty of it is how simple the actual setup is, right? You're essentially just vibrating a surface.
Exactly. A plate or a membrane, and then you cover it with something really fine, like dust or even a liquid.
And that's how the invisible energy becomes visible.
That's right. It shows you the areas of maximum and minimum displacement. So the particles get pushed away from the parts that are moving a lot, and they collect on the lines that are standing still.
Nodal lines.
The nodal lines. It's the pure geometry of the frequency right there for you to see.
What's so wild is how far back this goes. I mean, this isn't some 20th century discovery.
Not at all. We can go all the way back to 1680. A scientist named Robert Hooke was already seeing these patterns.
How?
He was running a bow, like from a violin,
Well,
along the edge of a glass plate that he'd covered in flour.
That's incredible. So how did it go from, a neat trick with some flour to an actual field of study?
Well, that's where the German physicist Ernst Chladni comes in the 18th century, 1787 to be exact. He's the one who really formalized it. He used fine sand on these vibrating metal plates, and that's how we got the famous Chladni figures.
Okay, and those are incredibly precise patterns, right?
Very precise. They show you the fixed structure of that sound wave. And it wasn't just solids. Michael Faraday later showed that liquids do it too. Faraday waves.
This is where it gets really interesting for me, though, with Hans Jenny.
Ah, yes, the man who coined the term cymatics.
He brought a much more rigorous methodology to it, using modern oscillators and different materials.
He did. And his work produced these images that, they often look like organic, natural forms. But his most famous discovery involved sacred geometry.
You're talking about the ohm.
Exactly. He noted that when he played the sound of a person chanting the ancient Sanskrit Om, the powder on the plate,
It formed a specific shape.
it formed a circle with a center point, which is the traditional ancient visual symbol for Om.
That is genuinely awe-inspiring. The idea that the sound for creation literally creates its own symbol in matter.
And what's just as beautiful, I think, is the physics behind it. The plate's physical shape, its structure, it actually predetermines all the possible patterns.
Ah, so the geometry is already there. It's latent.
It's built into the medium. The frequency you play just determines which of those inherent patterns gets revealed.
And speaking of revealing potential, whether it's the geometry under a surface or optimizing a business system, having the right structure is everything. This deep dive is sponsored by Embersilk. If you need help uncovering where AI agents could make the most impact for your business, or you need support with AI training, automation, or even software development, check out embersleep.com. They help you build the future.
And looking toward that future, cymatics is already influencing so much. Art, engineering.
Like Björk, right? Didn't she use it on tour?
She did. On her Biophilia tour, they projected the cymatics patterns generated from the bass frequencies live on stage. It's a way of letting the audience literally see the music.
That's cool, but the engineering progress is where I see the most optimism.
Oh, absolutely. There's a team, P. Chen and his coworkers. They've developed a way to engineer microscale structures using liquid templates.
So they're building things with sound.
Essentially, yes. The sound vibration acts as an instant invisible mold. You can dynamically reconfigure the structure of the material just by tuning the frequency.
Just by changing the note. That's
Yeah.
incredible.
It is. It shows we're learning to harness these fundamental ordered principles for real, tangible progress.
So if sound can shape sand and water and even micromaterials into these beautiful geometric patterns you see all over nature, from flowers to snowflakes, it just suggests this stunning fundamental order beneath all the chaos. And that gives you a lot of hope, hope that we can keep using these principles to build a better world.
It shows that even invisible energy operates under a law of elegant form.
If you enjoyed this deep dive into the geometry of sound, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.